Kia ora, it's Mrs. Goodson here, and this video is about haloalkanes. So the intention of this video is to look at what are haloalkanes, how are haloalkanes named and classified, how are they made, what are their physical properties, and what are the chemical reactions of haloalkanes that you need to know for level 2 chemistry. What are haloalkanes? Halogens are group 17 atoms in the periodic table, and the four you need to know are fluorine, chlorine, bromine, and iodine. They bond with carbon and they replace the hydrogen in alkanes. Now for naming, you use a prefix, so they're named as side chains. Prefixes go at the beginning of the name. So we have a look at some of the names here. We've got a fluorine atom attached to a methane atom, so we've got fluoromethane. And then we've got chlorine atom, so it's chloromethane. A bromine atom would be bromomethane, and an iodine atom would be iodomethane. Okay, so those are the names of the side chains that you need to learn. And if there's more than one, then you use di, tri, or tetra. Di is 2, tri is 3, tetra is 4 if there's more than one. For example, if there were 2 chlorines, you'd call it dichloromethane. For larger alkanes, you need to use a number. So we'll get rid of this. You need to use a number to indicate where the halogens are. So in this example, you've got propane, which is a 3-carbon chain, propane, and the fluorine atom is attached to carbon 2. So this is 1, 2, 3. The fluorine atom is attached to carbon 2, so it's 2-fluoropropane. If there's more than one type of halogen side chain, then you need to name them alphabetically. And you, for example, 2,2-dichloro-4-fluoropentane. Why don't you have a go at drawing that structure? 2,2-dichloro-4-fluoropentane. Pentane, remember, pentane is a chain of 5 carbons. Here are some more examples. This compound over here has 2 carbons, so it is iodomethane. Ethane, 2 carbons, and iodine, there's just one of them, so it's iodoethane. This one has 4 carbons. We're going to number them from this end to make the side chains this number as small as possible. So it's 2-bromobutane. Okay, so the bromine atom is attached to carbon 2. So this one here, 1, 2, 3, 4, 5. So it's pentane, that's our largest parent chain. And then we've got a side group of methane and a side group of chlorine. So it is 2-chloro-2-methylpentane. Okay, so the classification of haloalkanes depends on where the halogen is attached. In this example, the X represents the halogen. So if it's a primary haloalkane, if the halogen is attached to a carbon, this is the carbon here, it is attached to only one other carbon. So that one there, this carbon is attached to one carbon, so it is a primary, and we could write it like this. It's a primary haloalkane. A secondary one, here's our halogen attached to this carbon here. Was this attached to 1, 2 carbons? So it's secondary, and the notation for that is 2 with the degrees on it. So it's secondary, attached to a carbon which is attached to 2 other carbons. Tertiary is where the halogen atom here is attached to a carbon, and with this carbon here is attached to 1, 2, 3. So it's a tertiary. So it's, that's a notation, 3 naught, okay? And that influences the reactivity of the haloalkane. So how are haloalkanes made? Firstly, by the substitution of an alkane where a hydrogen is replaced with a halogen atom. Also addition of HX, where X is a halogen, to an alkene. So addition across a carbon-carbon double bond, or it could be Cl2 or bromine 2, iodine 2, or fluorine 2. Addition reaction across an alkene will give haloalkane. Or you could react an alcohol with PCl3, PCl5, or SOCl2, and that will get a substitution reaction, and you would get Cl atoms attached and replace hydrogen atom. That would make haloalkanes. So what are the physical properties of haloalkanes? So chloromethane, bromomethane, and chloroethane are gases at room temperature, while most other common haloalkanes are liquids. Haloalkanes are slightly soluble in water, and their solubility in water suggests that they are weakly polar molecules. Okay, so they are weakly polar molecules. These halogen atoms are slightly more electronegative than hydrogen, so that's what makes them weakly polar. Okay, now there's some key definitions that you need to know. We're talking about the chemical reactions of organic compounds. So there's three types of reactions I want to introduce here. Substitution, and that's where an atom is replaced by another atom or group. And then there's addition. For addition, you have to have a carbon-carbon double bond, which breaks and adds an atom or group of atoms across, and so that it becomes just a single bond, and then it's got things added to it. The opposite of addition is elimination, and a hydrogen atom and an atom's group is removed from two adjacent carbons. So this is, you take hydrogen from one carbon and the functional group from the other, and it forms a double bond. Okay, this is important. So carbon-carbon double bond is formed. Okay, so there are three chemical reactions that you need to know for haloalkanes. The first two are substitution. So it's replacing the functional group, which is the halogen. And then you need to learn the reagents. So this first one is with potassium hydroxide and water. It's aqueous. Aqueous means in water, and that makes an alcohol. The second one is a substitution. This is also a replacement. It replaces the halogen, and it replaces it with NH2. Okay, so the reagent you need to learn is the concentrated ammonia, NH3. And that's going to make an amine. An amine has this group on it, NH2. So that's two substitution reactions and an elimination reaction. So you need concentrated potassium hydroxide. This time is not water, it is in ethanol. So it's alcoholic, ALC. Okay, so that's a reagent we need to learn. And because it's elimination, it makes a carbon-carbon double bond, which is an alkene. Okay, so it makes an alkene. So I'll fix that on the PowerPoint. So an elimination reaction makes an alkene. Okay, so the first one is the substitution reaction. So this is aqueous potassium hydroxide. We've got our haloalkane here. We've got the chlorine atom, and that's going to get replaced with hydroxyl group. Okay, and that makes ethanol. All right, so we've got ethanol as our first example of a chemical reaction that haloalkanes undergo. The second one you need to learn is the ammonia one. So concentrated ammonia makes the amine. So here is our haloalkane, chloroethane. We're going to react it with concentrated ammonia, and this is going to be replaced with an NH2 group. Ethanamine is the name of this compound, and it makes HCl as well. But the main thing you need to learn is the organic compounds and how to draw their structures. Okay, so the elimination reaction makes an amine. As I said, it makes a carbon-carbon double bond. So our first example was chloroethane. So the chlorine is here. So this carbon and the hydrogen is next on the adjacent or the next door neighbor carbon, all right? So we're going to take this HCl and it's going to go over here and it's going to be eliminated. It's going to be removed. And so then this is going to be, it's going to make a double bond here. Okay, so it's going to make ethene plus HCl. And so this is with alcoholic or potassium hydroxide. We just do ALC. So it's in ethanol and we need some heat as well. Okay, so if the elimination is with a bigger haloalkane that is asymmetric, asymmetric means it's not even, okay, so I'm going to explain that a bit more. Then there are two products are possible. So here is our alpha carbon with a chlorine attached. Okay, if we look first at these two ones here, so we've got the neighbouring carbon has got this carbon has got 3 hydrogens on it, and this carbon has got 2 hydrogens on it. So the carbon with the least number of hydrogens is this one. So this carbon has got 2 hydrogens, and this carbon has 3 hydrogens. So the rule is that the carbon with the least number of hydrogens is the one most likely to lose it. All right, so this carbon is the poor one, so it's only got 2, so it's most likely to lose another one. So then the carbon-carbon double bond would form here between carbon 2 and 3, and here it is over here, and we will get 2 butene. Okay, 1, 2, 3, we get 2 butene. So that would be the major product. All right, so this one here with the blue circle becomes the major product, and this one here with the orange circle, this carbon has 3 hydrogens, so it is the least likely to form the double bond. And if it takes this hydrogen, then it's going to have a double bond here. Okay, and that would be 1 butene. So 1 butene is the minor product. So just to reiterate how you decide which is the major product and which is the minor product, if there's 2 products possible, we look for the carbon atom next to the carbon with the chlorine attached with the fewest hydrogen atoms attached. This is the carbon atom that is most likely to lose another hydrogen atom. In other words, the carbon that is the poorest is going to get poorer. This is known as Zaitev's rule. Okay, so this elimination shows an example when there's only one product possible. So if we look at the carbon that has the chlorine on it, which is this carbon here, and look at its neighboring carbon, and we're going to form a double bond here, there's only one possible place that it could form a double bond, so there's only one product in this example. So 1 chlorobutane reacted with alcoholic potassium hydroxide and with heat makes 1 butene. Okay, to summarize this video, we've talked about what haloalkanes are, and they have at least one halogen atom, fluorine, chlorine, bromine, or iodine. Haloalkanes are named with the halogens as side chains. They can be classified as primary, secondary, or tertiary. Haloalkanes can be made by the substitution of alkanes or the addition of reactions to alkenes, or the reaction of PCl3, PCl5, or SOCl2 with an alcohol. Haloalkanes are weakly polar molecules, so they are slightly soluble. They undergo substitution reactions with potassium hydroxide in aqueous solutions to make alcohols. They undergo substitution reactions with concentrated and they go elimination reaction with potassium hydroxide alcoholic to make alkenes. And just remember, if the haloalkane is asymmetric, there will be 2 products possible, and the major product will be where the carbon next to the halogen carbon with the least number of hydrogens, that will be most likely to lose another hydrogen, and that is known as Zaitev's rule. So there'll be a major product and a minor product. And so that's all you need to know about haloalkanes.